Hello, everyone. Good morning, good afternoon, good evening, wherever the world you are. I hope you're doing great. Welcome to another session with Microsoft Learn, Microsoft Zero to Hero community. We're so glad to have you here today with David, Lorenzo, with an interesting topic of build your own Copilot with .NET Azure. So excited for this session. I'm not going to take that much time. I'm so excited to pull him on the stage and give the stage to him so we can start with the session. Gonna quickly move to with my slides. So as usual, our slogan in Microsoft Learn is mainly in the communities, in the learning rooms also, it's make it your homepage. So make Microsoft Learn your homepage because we are all on the same ship going towards learning in a daily basis. And I'm so excited that checking Microsoft Learn on a daily basis and just checking for the updates. So this is exactly what we love to do all together in the community. So you can check learning rooms in aka.ms/learning rooms, and you can join to Microsoft Zero to Hero community in there, and also other learning rooms that all professionals, learners, fresh graduates, students, and all together are sharing knowledge. You can ask questions, you can answer questions, and this is exactly the aim of the learning rooms within Microsoft Learn Tech community. With that said, our first episode of Microsoft Backyard is shared. It's on YouTube channel. It's an interesting program from the community. It's not technical videos that interviews we do with professionals, with Microsoft employees, with professionals from all over the world. It's not technical questions or technical presentations. So we are trying to ask for their personal experiences in a daily basis. How do they start their daily work? How do they manage their tasks? How do they manage their personal life? Or how to stay motivated? And this is exactly what we achieved with Microsoft Backyard. So we can watch first episode, and the second episode is on the way. With that said, our July calendar was perfect and it still is perfect. We have today David, and after this session, we have two more sessions from the month July, and then August sessions will start, and we already published August calendar as well. It's on the page in learning rooms, and so excited with that amazing speakers with every month and all those experiences and the knowledge they're sharing. Thanks to all, thanks to everyone. And last but not least, the code of conduct, as usual, we have for all sessions. So being aware of each other, friendly and patient, welcoming, respectful, and opening to questions and viewpoints, understanding differences, and kind to consider to others. With that said, I'm going to add David to the stage. Hi, David.
Hello,
Very welcome.
hello. How are you, Amit? Thank
Fine,
you
thank
for
you.
having me here.
Glad to see you here. How are you today?
Yeah, very well, very well. Very excited to learn to share all my knowledge about Copilot with all the community, and thank you for letting me be here with all of you. Thank you.
Definitely, definitely. So happy to have you here. So I'm just gonna quickly remove my screen from here and add your screen. Here's your
Yeah.
screen. With that said, and good luck. I'm gonna go to backstage, and the stage is yours.
Okay. Thank you, Amit. Okay. Yes. I want to thank you all the Microsoft Zero to Hero for letting me to share my session here with all the community. We will talk about um, how to build your own Copilot with .NET and Azure. Okay, it's an interesting topic that is just the main topic of the last years and of the last 2 years. Last year, in all the tech community, Microsoft is on the head of the AI revolution, and we have a lot of technologies in Azure and with a lot of libraries in .NET to facilitate this building of this type of application that will help our companies to grow and to be more productive. Just presenting me 2 minutes. I am David Lorenzo. I work to Prodware company here in Spain as a solution architect. I have a back knowledge of .NET on the last 10 years, working on the web part mainly. I also, on the last 2-3 years, I've been involved in Power Platform projects last since my joining to Prodware, and the last 2 years after the explosion of artificial intelligence, I have been very interested on all the topics about RAG application, Copilot application, how to build it, how to improve it, and just that's the reason why I am here now, today to share all this knowledge with you, with all of you. I want to mention also Warandinga Tech, which is the logo on the right side of my face. That is a community we have with some colleagues here in Tenerife, in Spain, and we have also a YouTube channel. I will mention on the last slide at the end of the session that we share all type of knowledge, mainly Microsoft content, but also another type of tech content that can be of interest from you. That said, we can see the agenda for today. I don't take too much time on the slides, so I want to show you mainly Azure content, Azure components, and the code of the Copilot application, so you can take a look at how it is built and how you can improve. Also, I will give you some resources to extend this basic application and so interesting documentation you can study to understand all what is in the back of this application. Okay, so first we will go to see what is RAG, what is fine tuning, and what are the difference between them. Then we go to see the architecture diagram for this application and a little bit improved version that we can build using caching. Then we go to the demo time. I will show you the Azure components. I will show you the application in use, of course, in the first place. And then we will see also the code, the main part of the code. And then I show you how to tweak the configuration so you can test with different approaches. And finally, I showed you some resources, some articles, interesting articles of the tech community of Microsoft that you can study to improve this type of application. So what is RAG? RAG, some of you maybe remember Goku, and Dragon Ball is a series of my child time. I see it too much, and the RAG pattern here in artificial intelligence have some similarities to this series of Dragon Ball. So you remember when Goku converts into the Super Saiyan, it gets a lot of more power, it gets more stronger than there was when it's not converted to Super Saiyan. So the RAG is mean that retrieval augmented generation is a pattern that you can use in your artificial intelligence application to convert it to a more stronger, to a more powerful application by injecting the specific content that you want to query to. So, for example, if you are building a Copilot application to query information of your company, like the one I will show you in a moment, you want that your application don't do hallucination, don't invent information of your company. You want that your application gets only the documentation that your company has and query only in that documentation. So this is what RAG pattern will allow you to do. Okay, then there is a lot of variation of RAG patterns that you can use depending on your needs, that you can use to improve the efficiency of your application. But for the moment, I will show you the basic pattern, and then I will give you a few articles, a few documentation that you can study to extend or improve this pattern, okay? So what is RAG? What is fine tuning? I have some difference here because when you are using an artificial intelligence, or when you are building a Copilot, you can use directly query to the model, or you can use the RAG pattern. That is a prompt injection that you can do, a prompt augmentation, let's say, not prompt injection, prompt augmentation that you can do before querying the model to make like a specific query to the model, and don't let the model to invent all the responses that will give you. Okay, so when you should use RAG and when you should use fine tuning. If you take a look at the training time, we can see that the RAG is faster and the fine tuning is slower. Mainly because the RAG does not need to make any training. So you can use the model like it is, and just query the model with a prompt that you will augment with the information of the company. On the other side, the fine tuning is slower because you have to retrain the model, and you have to, it depends how much slower it is, depends on the model size, on the computation you have to retrain the model, and on the data set that you use to retrain the model. Okay. If you take a look at the computational cost, we have low computational cost for the RAG, high computational cost for the fine tuning. Is on the hand with the training time. So we don't need to train the model. We have low computational cost. We need to train the model. We have higher computational cost. The precision, here is a difference. So the RAG is better for existing content, for being a domain expert, also for changing the content dynamically. So the RAG will allow to build different application of different contents with the same model. But on the other side, the fine tuning is better for complex tasks, for learning patterns, for things more complex that you have to retrain the model in specific cases, and let the model to learn new responses. Okay, so that's the main difference here. If we take a look at the model size on the RAG pattern, there is no change on the model size. We use the same model, but on the fine tuning, it depends on the algorithm and the model size that we have before the retraining, the fine tuning process. So it usually will get higher on the size. What about the training data? So we don't need training data for the RAG pattern. We need training data for fine tuning. On the RAG pattern, we need only the data that we will use to augment the context. We will retrieve that data. We augment the context, the prompt, and then we query the model with that prompt with a context that the model will use to answer our question. Okay, so if we take a look at the memory, of course, we will need higher memory because we need to save that external source of information, the source of knowledge, the knowledge of our company. For example, if we are if we have a document library, for example, we can convert. We will see later. We can convert that library into into chunks. Save that chunks into the vector database, and then we can query that database. Okay, what about the fine tuning? Is lower the memory. We only need a data set to retrain, to fine tune in the model, and then the model maybe will increase the size, but is lower that size, that the size we need to save the external source of information. So the model will ingest that information inside of it, and the size of the model won't increase linear to the size of the data source that we we train with. And last but not least, the scalability. Of course, the RAG is more scalable than the fine-tuning. The RAG pattern, we can change the query, the knowledge, the source of knowledge dynamically without retaining the model, without changing the model. Just we have to change the query, the source of data. Maybe we change the system prompt, the basic prompt, and it's it. We get another Copilot with implementing the RAG pattern that serve us for another topic is different from the one that we have before. On the other side, with fine-tuning, we will need to retrain the model with the new information every time. Okay, so this is the main difference. I won't take too much in here. Now we can see the architecture of the Copilot, that the basic RAG architecture that we can have. Okay, on the first time we have the data sources where we can have different different types of information. We can have images, we can have documents, we can have presentations, spreadsheets, text files, PDF files, and so on. We will need to extract the data from that files. Then we will need to chunk that data. We will talk about chunking techniques a little bit at the end of the session. I will give you some links on that, but this just take into mind that is one of the more important process of all the RAG architecture. If we do a bad chunking, we will get bad results in our responses. So the chunking process is very important. It's different in every case, so we have to study what we want to get, and then based on that, we will do different chunking techniques. Then with that chunked data, we save it into a vector database. In this case, we will use Azure AI Search. And then from the client application, from our Copilot application, we will make a question, okay? We will make a question to our API, and then the API, we will query, first of all, that knowledge database, that vector database, and then get the more relevant documents, the more relevant chunks of information that is more relevant to our query. With that information, we will build a prompt that have that context of information inside the prompt, and then we will get the model, the LLM model, the LLM to build a response in a human-friendly form. Okay, then that response will go to the client application. We will see this in working in a moment. But let's take a look our Copilot architecture. What components? This is the previous architecture was a general architecture for RAG. This is our architecture for the today Copilot I will show you. So we will have an app made in Blazor. We will have an API built inside Azure Container Apps. Then we will have also a Azure storage account where we will save our documentation, the PDF files in that case. Then we will use Azure OpenAI to make the embeddings of the data, and also to help us in the generation of the human friendly response. And also we will use the Azure Cognitive Search, Azure AI Search, which is the current name, to help us to save the chunked data and help us to retrieve the more relevant pieces of information when we are querying the model. Okay, and I want to show you a last slightly improved architecture. We won't see this in action, but it's like an idea that I want to give you if you want to build this for real use. So every time you do a question, you have to make all this process. So the UX receives the question from the user, then it gets to the API, and the first time you need to query the vector database, in this case the Azure AI search, to get the more relevant documents. Then you need to take that documents and construct the prompt with the context of that documents and the rest of the question from the user and the chat history and so on. Then send all this prompt to the Azure OpenAI service to get the final response of the to get to the user on the app and on the client app. So what about if the user asks the same question again, or another user that is using the same map, the same resources, ask the same question again? We can intercept that question and first, instead of going directly to find the documents and construct the prompt and so on, we can query a caching system like Azure Redis Cache, where we can save pairs of question answer, and then we can query before. If that question have been made before, we can take automatically the response and send to the user, and we save all this resource consumption here. So what we need to do is when the first question is asked and we don't find it on the cache, we will generate the question by going to here to the Azure AI search, taking the documents, building the prompt, going to Azure OpenAI and generating the response. And before we respond to the user, we save the question and the response, the generated response, into the cache. So the next user that asks the same question, we will first go to the cache, take a look if there is the pair, if there is a question answer pair for that question. If there we find a match, we respond to the user, and we are saving a lot of resource consumption. This is a slightly improved. Of course, we need to take care of how much time we get the responses or the rows into the cache, and that depends on how much and how many refreshing the content here is. So if we have, for example, different documents that get refreshed once a month, then we can refresh the cache once a month. Also, we can use a more advanced technique like caching tags, where we correlate tag with document in the source of knowledge, and when that specific document gets refreshed, we remove all that cache tags that reference to that document. So we get a dynamic cache that gets refreshed only when needed. So that's different room for improvement here, but I think it's an interesting topic that we can take care when we are building this type of applications. And that's all for the slides. We will go to the demo, and at the end of the session, we will have room for questions, and also I will show you some interesting resources that you can take a look. So let's switch here to, okay, I want to show you first the application in use, okay? So this is a Copilot application where we can chat with your own data, okay? In that case, we have sample data from Microsoft that is about different health insurance that the employees can have to improve their healthy life. And then we have here some question that we can click to make it more general. Of course, we are querying this question, what happens in a performance review. And then on the back, if you remember, we first go to Azure AI Search, we find the documents that are, in that case, we have 3 documents that are relevant to our query. Then with that documents, we inject into the prompt. We will see this process later. We inject this into the prompt. We go to the LLM, to Azure OpenAI, generate a human-friendly response, and then this is the response, okay? So in this process, we also are doing some improvements, like we are telling the LLM that explain us the thought process that he follows to generate the question, the response. So it tells us that I found the information in the employee handbook of Contoso Electronic, which provides a detailed explanation of their performance review process. Okay, so this is what the LLM has think inside of it to generate the response based on the supporting content. And also, and this is very, I think is very engaging for the user, we generate follow-up questions. What's that? So this is our question that are related to the topic that we are talking about. So we are talking about what happens in a performance review. This is a specific answer. And then we have 3 follow-up questions that are: how are performance ratings determined? Are there any consequences for poor performance? Can employee request a review outside the annual schedule? So we click on that. Then we also include that chat history on the on all the process, and then we can continue to generate a different follow-up question to get the user engaged with our application. Okay. Okay, so that's okay. If we, of course, we can open the document. So we will see later what chunking process we follow here. It's very simple chunking process, but I can advance with that we have only PDF in the source of knowledge, and we chunk split page by page. So if I have a if we have a 100-page PDF, so we will have 100 chunks of that PDF, and then when we query the Azure OpenAI, the Azure AI Search, we will get 3 of these chunks. So we'll get 3 of these pages, and in this case, the one that have the more according response for this question is this one that we can query here. For the other one is another page. Okay. So we will take a look now a little bit to Azure. So we have 2 main parts of this application. We will see later all the code of the API, but first I want to show you what components we have in Azure. So basically, we have here resource group with all the components, and then I will show you the main of it. So we have a storage account. In the storage account, we will save the documents without chunks. So the source of knowledge documents, that source of knowledge can be a SharePoint library, can be any type of saving system that we have in our company. In this case, we use our storage account, and we save the PDF files there in the storage account. Then we have, of course, Azure OpenAI. Inside Azure OpenAI, we have 2 deployments. In this case, we have an embedding deployment that will allow us to convert from text to vector. So this is the ADA algorithm, the ADA model from OpenAI, and then we will have the GPT 3.5 Turbo model to serve as the LLM. So with this model, we can send a prompt and get a response, a human-friendly response for our responses of the application. Okay, then we will also use, I won't show you, but application inside. This can be useful if you want to monitor all the queries, all the performance, all the failures of your application. It's useful to have an application insights connected to the front end, to the API, to the functions, and so on. Also, we use Key Vault to keep our secrets. That's not the part of this session, but is a best practice, of course, of if you use Azure, to use Key Vault to keep your secrets safe. And also we have the search service. This is I want to show you inside, because this is one of the main part of the application. We have this is the AI Azure AI search, where we keep all the information after chunking it. We keep all the information here, so we can see here one search, for example. We have this. We have in the index, we have different documents, so you can see each of these value object is a chunked document, a chunk of the main document, and we keep a reference to our main document. We keep the content in plain text, and then we have the embedding of 1,536 dimensions, which is the OpenAI ADA embedding that is generated from this content. Okay, so these have the meaning of the content, and we can then query, but we can do a semantic query to this OpenAI search, to this Azure AI search, sorry, to get the 3 or the X more relevant documents results from here, in order to augment our prompt and generate a good response to our users. Okay, and then finally we can take a look. We have different function apps. This is used to just help in the indexing process, in the chunking process. It's not in the query process. It's not in the general use of the application, but is only using on the indexing process. We will take a look a little bit at the indexing code, but only the use of this function is only to take a specific text and convert to an embedding array. So this is the use of this function. Of course, you can architecture your application in different ways. This is one type, one way to do it. But of course, you can use more functions and less APIs and so on. You can vary your architecture here. And finally, we have the container apps, where we keep our API, our client application to use by the customers. And the last I want to show you is the document intelligence. This service of Azure will help us to convert, for example, different documents that are not text documents, like, for example, PDF documents or Word documents. This help us to convert to plain text in a way that we will get a quick process we don't need to invest too much effort to develop like a script application that process and parses all the document and extract all the text. This is more convenient way to do it. Of course, is a paid process. We can measure if we need to use or not. I recommend to use document intelligence if you can, because you will get a more efficient result in this case. So these are all the components. We can see it all inside this resource group. And of course, the service plan is keeping up the container applications to keep our client app and our API. So these are the Azure components, and then we will switch to the code. In this case, I can show you, this is the solution that we will debug in a moment. But for the moment, I want to show you the main projects. Okay, starting here in the minimal API. Okay, the minimal API is an API that we'll use to connect the client application with our Azure service. So we connect we receive the questions from the users, we query the Azure AI search to get the more relevant documents, we construct, build, augment the prompt, then we go and connect with the LLM service to get a useful response for the user, and then we build all the follow-up question and so on, and then we respond to the user. Of course, the embed functions, this is part of the process of chunking the data. This prepared docs is a console application that we will use to split out the PDF files, and then using the embed functions, we will convert each chunks of text into an embedding array, and then we will index that into the Azure AI search. So this is done by this background process that we can have, of course, all the time running, or we can run scheduling and so on. And then we have the client app. This is a Blazor app. We have also different views here. I don't go in detail on that. You can build the client app with the technology that you want, with React, with Razor, with .NET MVC application. What you prefer, what your company use, that's not the more relevant part, I think, but I like a lot Blazor, and I think it's a good technology to build the dynamic front. Also, finally, we have shared libraries here with models and components for the Blazor app. This is just for refactoring a little bit the solution, and we can reuse this component and different front-end app if we had it. Okay, and we can go and take a look at the prepared docs program file, which is in charge of chunking and indexing the documents. So in this case, we are just in the main method. We are just getting the documents and making a loop through it, and in each document, what we do is to split into pages. Okay, we for the moment have only allow PDF and images file. We won't show the images here in this session, but we will show only the PDF. But of course, we can index more type of documents, like Word documents, like TXT documents, like video documents using the Vision API of Azure. So the sky is the limit here. It's only up to you that you want to implement different indexing methods. Of course, for each PDF file, what we do is we upload first to the blob storage to keep it there in the blob storage, the original file, and then we do here a page loop where we upload every page also to the storage account, so we can then, like we see here, we can query a specific page of the chunked document, and then we also generate the embedding of this text. We extract the text here from the page of the PDF, and then here is using the document intelligence from Azure, and then we index it into the Azure AI search index, which is the one I showed you before. Okay. So this is the indexing process. The chunking process is not a very optimized chunking process. It's simpler chunking process just to show you the result of the application. In the real scenario, what I recommend is to index, like there is a lot of of chunking process. I like so much one that is named semantic chunking, because you split the documents by sections and subsections, and then you keep a correlation between the parent and child sections in the Azure AI search. So when you are querying about a specific topic, you can get the chunks that are specific to that topics, and not get information that may be very similar but is of another topic. So that's why it's very important to make a good chunking process depending on the source of information that we have, depending on the type of information that we have. Okay, and then to do not extend too much here, I want to show you a little bit the main process of the RAG pattern. Okay, I will send here a question. We will get a timeout, of course, because we will spend too much by taking out in the debug. But I want to show you in the first part. We will get here the history of the chat. Okay, if we take a look here, we have different question and answers. So we get here the history of the chat, and then we go through the code. We use the semantic kernel, which I will give you a link at the end of the session to extend the information. It's very useful to integrate different services into our Copilot application. And then we build here the chat, the OpenAI, the Azure OpenAI embedding service and the completion service to get the answer. Okay, so we get the user question, and then we get the embeddings of the question. Here is the 1, 5, 3, 6 dimension array. Then we use vector retrieval mode. So we jump out this part, and then we get the 3 more relevant documents, as we said you before, for this query. Okay, this is querying the Azure OpenAI, the Azure AI search, sending the query, sending the embed, the different configuration for the query. I show you later that there is different search modes here. You can use also the semantic ranker. We get the embeddings, and then we get, this is the question embeddings that we have converted here up there before, and we request the top 3 documents. So that's why we get 3 documents. We can, of course, increase that number or reduce it. we join up the document content, and then we build up the chat history. We join up with all the rest of the messages, and then we don't have images here, but we could use. And here is where the RAG takes into the game. So we augment, this is the main prompt, we augment the prompt with the document contents here, and we let we tell the LLM to just use this source of knowledge and not anymore. So that's, we remove here the hallucinations that the LLM will do it if we don't do that that pattern. And then of course here the cancellation token, I think, will kill us. So I will send again the query here. Yeah. So we go and stop there. Yeah, so we get the answer. This is the answer for our question that we have sent it the different documents. We have sent that it gives us the answer and the thoughts, brief thought on how you come up with the answer, of course. And then here we build the follow-up question. So we send another query and did and say generate 3 follow-up questions based on the answer you just generated. We put up the answer here, and then we will get the follow-up question, and the follow-up question, we build all the response object, and then we just respond to the front application. And here we have the thought process, we have the supporting content that are the different files that we have used to build the answer. Here is the answer, and here are the follow-up question that we have requested to build. Okay, and just on the last part, I want to show you, in this application, we are able to of course, change to dark mode. This is a nice to have feature, but of course, we have here different search types, okay, different retrieval modes that we can use to test the different results. So for example, now we are using the vector search. In the vector search, we only do a vector comparison in the database, but Azure AI search allows us to make a hybrid search where he will do a vector search and a keyword search and merge the results and take us a different response. So let's take a look at the different responses. So I will just ask this question. Let's remove the breakpoints here. Okay, let's remove that one. Yeah, so making a vector search, I get this response. Let's do the same question, but making a hybrid search. Let's see what happens. So we get a different response. Of course, we can also put here 5 documents, and we can check the semantic ranker and then ask the same question and then see if it responds different. Okay, you see, this is more extended response. This is more specific response. The supporting content now have 5 elements instead of the 3 here. So with this application, we can also tweak these settings to just take a look and test the different results. We can, of course, give more instructions here to override the prompt, exclude some categories. You can try out. I will give you the repository of this application so you can try out. And I think no more interesting here. This is the main process of the application. Of course, I will show you now different resources that we can just use to extend our knowledge. This is the repository, okay? The repository for this application. You can download. It will give you all the source code you have just seen. It will allow you to generate, if you have an Azure subscription, an Azure tenant, it will allow you to install automatically all the resources. Of course, you will have some money to do it, and you can try out this combination of patterns and maybe tweak some different settings to get a better result. I recommend also this YouTube video, which is working with this application also, and give you some overview, like the one I show you today, with different combination of configurations and different architectures. So it's very useful too. And of course, I recommend also take a look at the official documentation of Azure OpenAI and semantic kernel. This is very useful. The semantic kernel, if you will use .NET to build the applications, is very useful to simplify the integration of the different APIs. You can switch from OpenAI to Azure OpenAI to using different LLM models like P3, like GPT 3.5, GPT 4, and so on, just by changing different parameters. So it's very useful to take a look at semantic kernel. This application I show you today use semantic kernel, so I recommend to take a look at it. And what's next? So I put here different links just to take a look at chunking techniques. That's like I mentioned you before. It's very important to take a good chunking technique in the beginning of your indexing process to save the information in a way that you can query then and get the better results for what you want to get. So it's there is no a magic point. There is no a unique recipe to get that, but it's very important that you analyze what you want to get and then use the more indicated chunking technique in that case. Also, I show you today the basic RAG pattern. There is more extended RAG applications. There is graph RAG, which is like the one I show you today, but with a second augmentation process that will query a knowledge graph. We can have a knowledge graph in our company, and then we can query our knowledge source of data, and then query our knowledge graph, then join that information together, and then build a prompt and query the LLM to get the human-friendly response. So this is like if it is well implemented, you will get a more specific, a more detailed answers that the one I show you today. Advanced RAG, this is very new article on Tech Community blog, just from yesterday, as you can see here. I haven't read in deeply, but I think it's very interesting because it's taking up knowledge graph indexing, recursive retrieval queries, three-mode summarization. So this is like if you have different documents that have a section, subsection, and subsection of subsection, and so on, and you can make a summary of all the tree from the leaf to the root. Okay, so making a semantic hybrid search, subquery engine with Azure AI Search. We have done a semantic hybrid search today. Just I show you here. If you tweak this setting, hybrid and semantic, you are doing that type of search. And then you can use a Microsoft Graph RAG that to just augment with more information the prompt. So there is a lot of techniques like that one to in order to improve the RAG pattern. And then last I want to show you is the RAG evaluation. So this is, for example, you can evaluate the different responses that a RAG pattern gives you and auto-evaluate, of course, and then you can make the application to learn what source of information is better. So if you do, for example, a question, you do 3 different queries to the knowledge of, in this case, to Azure AI Search, and take 3 different groups of documents, and then you generate 3 answers, and you can then auto-evaluate each answer to see what is better. Then you can have like a auto-review process to give of the 3 answers, that one is the better. So that 3 documents were the better related documents of all the process. That's an example, a simple example. Here is 2 articles just to give you more insight on that point. And it's all. I thank you, all of you, to being here. I just remember here my network profiles. If you want to be in contact with me, I remember here the Warandinga Tech community. You can subscribe to the YouTube channel, and of course, thanks, and I appreciate your company there.
That was an amazing session, David. Thank you so much. I really enjoyed it. I see a question in the chat. Enoch Friends, I hope I pronounced it correctly, says, can you drop the repo link and other related links in the chat, please? So if that's possible, to share it also.
Yeah, of course. I will just stop.
You can share the links with me, because I will promote the record afterwards. And by the way, once we start the streaming, it will be immediately available on YouTube. And afterwards, I will post it on LinkedIn, so I can post it together with the links you share with me, so everyone can access it.
Yeah, I will send you all these links of the last 2 slides, and you can post join with the video. Yeah.
Amazing. Okay, so Enoch, we will be posting the links on LinkedIn and also other socials, and also learning rooms, and also everyone. I guess those links are really helpful and resourceful related to the session. Amazing. If there are no more questions, I guess we're at the end of the session then.
Okay. Thank you, Amit, for being me here. Thank you to all the Microsoft Zero to Hero community, and hope to be with you in the future.
Of course. Looking forward to have you again on the stage. Thanks everyone for joining. Have a great evening.
Thank you. Bye.